Welcome to AWS Mastery Labs, turning AWS chaos into clarity with bite-sized tutorials, hands-on labs, and exam-smashing tips. In this video, we'll explore the key tools and techniques for monitoring and gaining insights into your Amazon S3 usage. From understanding usage patterns to improving data management, we'll cover powerful features like S3 Storage Lens, S3 Inventory, Storage Class Analysis, Server Access Logs, and CloudWatch integration, helping you unlock deeper visibility into your S3 environment. Let's get started. Amazon S3, Simple Storage Service, is a foundational service in the AWS ecosystem, designed to offer secure, durable, and highly scalable object storage for a virtually unlimited range of use cases. Often described as infinitely scaling storage, S3 can seamlessly accommodate the needs of a single developer or the most data-intensive enterprise workloads, without the need to manage infrastructure or worry about capacity planning. One of the standout features of Amazon S3 is its simplicity. It provides a straightforward web services interface, available through the AWS Management Console, SDKs, CLI, and REST APIs, that allows users to store and retrieve any amount of data from anywhere on the web. It also integrates effortlessly with a vast array of third-party tools and AWS services, enabling developers to build complex workflows and scalable systems quickly. S3 is known for its exceptional durability, with AWS guaranteeing 99.9999999%, 11 nines durability for objects by redundantly storing data across multiple facilities. This makes it an ideal choice for backup and restore solutions, data archiving, and disaster recovery scenarios. S3 also supports a broad set of features like lifecycle management, replication, encryption, and access control, giving users fine-grained control over how their data is stored, accessed, and managed. Because of its reliability, scalability, and performance, many modern web and mobile applications use S3 as their content backbone. It's especially popular for serving static assets like HTML, CSS, JavaScript, images, and videos, often in combination with services like Amazon CloudFront for global content delivery. Businesses leverage S3 to build data lakes, support analytics workflows, host static websites, manage logs, and much more, making it not just a storage service, but a key enabler of innovation across industries. Amazon S3 offers a comprehensive portfolio of monitoring tools designed to provide deep insights into storage usage, access patterns, security posture, and cost optimization opportunities. These tools empower users to effectively monitor, analyze, and automate data management, ensuring their S3 environment is both efficient and secure. At the heart of this toolkit is S3 Storage Lens, which delivers organization-wide visibility into storage usage and activity trends with powerful metrics and actionable recommendations. S3 Inventory helps you keep track of objects and their metadata across buckets, making it easier to audit and manage large datasets. S3 Storage Class Analysis identifies data that can be transitioned to more cost-effective storage classes based on access frequency. S3 Server Access Logs provide detailed records of every request made to your S3 resources, enabling security reviews and operational debugging. Lastly, integration with Amazon CloudWatch allows you to set custom alarms, visualize metrics and dashboards, and take automated actions based on storage activity and health indicators. Together, these tools form a holistic monitoring framework that supports intelligent decision-making, improved governance, and optimized storage operations in Amazon S3. Amazon S3 Inventory is a powerful feature designed to simplify the process of auditing and managing the contents of S3 buckets, especially at scale. It provides a systematic way to generate and export detailed reports that list the objects stored in a bucket, along with their associated metadata. These reports are generated in CSV, ORC, or Parquet formats, making them easy to consume for downstream analytics or compliance workflows. At its core, S3 Inventory helps administrators keep track of what's stored within their buckets. This is particularly valuable for large environments with millions or even billions of objects, where manually listing and inspecting items becomes impractical. Each report includes essential metadata such as object name, size, last modified date, storage class, encryption status, and version ID if versioning is enabled. What makes S3 Inventory even more flexible is its configurability. Users can define multiple inventory reports per bucket, targeting specific prefixes or storage classes. For instance, one report might focus on objects in the logs prefix stored in the standard storage class, while another targets data under archive using the glacier class. This level of granularity allows teams to tailor reports based on operational, compliance, or business needs. From a compliance perspective, S3 inventory plays a critical role in verifying encryption adherence. The report clearly marks whether each object is encrypted and, if so, the encryption method used. SSES3, SSEKMS, SSEC, etc. This visibility allows security teams to audit encryption policies effectively and take action on any unencrypted objects that may pose a risk. Inventory reports also support optimization efforts. By analyzing metadata over time, organizations can identify objects that haven't been modified or accessed recently, making them candidates for transitioning to more cost-effective storage classes like S3 infrequent access or Glacier. This proactive data lifecycle management can lead to significant cost savings. S3 inventory reports are stored in another S3 bucket of your choice, allowing seamless integration with services like Amazon Athena for querying, Amazon QuickSight for visualizing, or AWS Lambda for automated processing. Reports can be generated daily or weekly, depending on how frequently you need to analyze your storage. Amazon S3 inventory is a vital tool for storage visibility, compliance auditing, and cost optimization. Whether you're maintaining regulatory standards, ensuring encryption across all objects, or trying to reduce costs by managing aging data, S3 inventory delivers the transparency and flexibility required to operate S3 environments efficiently. Amazon S3 inventory operates as a scalable, managed solution that automatically generates comprehensive listings of the objects stored within your S3 buckets. Designed to streamline the monitoring, auditing, and governance of your data at scale, S3 inventory is particularly effective for environments managing millions or even billions of objects, such as large data lakes or archival systems. At its core, the S3 inventory process runs on a scheduled basis. Users can choose between daily or weekly report generation, depending on how frequently they want to analyze their bucket contents. When the inventory job runs, it scans all the objects in the configured bucket and compiles a complete report of every object at the time of execution. This list includes critical metadata, such as object name, size, last modified timestamp, storage class, and encryption status, essential for both operational oversight and compliance auditing. The reports can be exported in one of three widely used formats: CSV, ORC, or Parquet, ensuring compatibility with a wide range of analytics and data processing tools. Once generated, the reports are delivered to a destination S3 bucket of your choice, which can be in the same account or a different one, as long as the appropriate permissions are in place. One of the powerful features of S3 inventory is its native compatibility with Amazon Athena, made possible by the inclusion of Hive-style symlink manifests. These manifests allow Athena to query the inventory data without the need for manual schema definitions or pre-processing. With Athena, you can run complex SQL queries directly on the inventory reports to identify patterns, anomalies, or opportunities for optimization. For example, finding objects that are not encrypted, spotting duplicate content across buckets, or isolating objects that haven't been modified in months. This capability makes S3 inventory invaluable in understanding the topography of large dynamic storage environments, particularly data lakes that span multiple buckets, prefixes, and storage classes. In such cases, gaining a holistic view of the stored data, how it's distributed, what policies apply, and where inefficiencies lie, is nearly impossible through conventional listing mechanisms. S3 inventory fills this gap by delivering structured, query-ready datasets that can power deeper insights and automated remediation. From a cost perspective, S3 inventory is highly cost-effective, priced at just 0.0025 per million objects listed. This minimal cost is negligible when compared to the operational value it provides in terms of governance, optimization, and compliance. Amazon S3 Storage Class Analysis is a powerful feature designed to help users understand how their data is being accessed over time, enabling informed decisions about transitioning objects to more cost-effective storage classes. By continuously analyzing access patterns, it offers data-driven insights that are crucial for optimizing storage costs, particularly in environments managing large volumes of data with varying access frequencies. At the heart of S3 storage class analysis is its ability to identify trends in data access. It monitors how often objects are accessed and evaluates whether they would be better suited for storage classes such as S3 Standard IA, Infrequent Access, or S3 Glacier, which offers significantly lower storage costs for data that is not frequently used. These insights are not based on static rules, but on actual usage behavior, providing a more intelligent and customized approach to storage management. The analysis can be applied with fine-grained control, not just at the bucket level, but also down to specific prefixes or tagged subsets of objects. This enables organizations to tailor their optimization strategies to different segments of their data, ensuring that critical, frequently accessed content remains readily available, while older or less used data is cost-effectively archived. However, meaningful results from S3 storage class analysis aren't immediate. The tool requires at least 30 days of data collection to establish reliable access patterns. This historical view is essential for identifying data that has become cold and no longer requires high-performance storage. The insights gathered through this analysis are conveniently visualized within the AWS S3 console, providing an intuitive interface for reviewing storage usage and access trends. These visualizations support clear decision-making and facilitate the setup or refinement of S3 lifecycle policies, automated rules that transition data between storage classes based on usage criteria. By aligning these lifecycle policies with real-world access patterns, S3 storage class analysis helps avoid common pitfalls, such as prematurely transitioning frequently accessed data or failing to move rarely accessed data to cheaper storage. It ensures that your storage strategy remains both efficient and cost-effective. Additionally, users have the flexibility to create multiple configurations for different data sets or workloads. Whether you're managing media assets, archival records, or analytical datasets, you can customize your analysis settings to fit the specific behavior and requirements of each data group. The results of the S3 storage class analysis reveal some key insights into current storage usage and access behavior. A significant portion of the data, 6.39 petabytes, resides in the S3 standard storage class. This indicates that the majority of objects are being stored in the default high-performance tier, regardless of their access frequency. However, the analysis also shows that only between 16% and 30% of this standard storage is actually being retrieved or accessed. This gap highlights a major opportunity for optimization. A large volume of data in standard storage is rarely, if ever, accessed, yet it continues to incur higher storage costs. Additionally, the S3 standard IA, infrequent access, storage class, which is specifically designed for data that is not accessed frequently but still requires rapid retrieval, is currently underutilized. This suggests that the existing storage configuration does not align well with the actual access patterns of the data. Based on these findings, implementing a lifecycle policy that transitions infrequently accessed data from standard to standard IA or other lower-cost storage classes would result in significant cost savings. By aligning storage class transitions with observed usage patterns, organizations can optimize their S3 costs while maintaining access efficiency for frequently used data. The illustration on storage allocation by object duration offers a deeper look into how long data remains in Amazon S3 before being accessed or retrieved. This breakdown by age bands reveals telling patterns about storage behavior and helps inform decisions around lifecycle management and cost optimization. Starting with the 30 days category, we see 486 TB stored, yet 974 TB retrieved, which indicates a very high retrieval activity for recently stored data. This suggests that this short-term data is frequently accessed, making S3 standard a suitable choice for this band. However, as we move to older data segments, a different trend emerges. Between 30 to 45 days, there are 574 TB stored, but only 57 TB retrieved. Similarly, in the 45 to 60-day range, 665 TB are stored, with just 60 TB being retrieved. These low retrieval volumes, despite significant storage, show a marked decline in data access after the first month. The pattern continues in the 60 to 90-day range with 1.56 PB stored, but only 159 T retrieved, and again in the 90 to 180-day segment with 923 TB stored and 99 TB retrieved. Finally, in the 180-day group, 2.25 PB are still stored, yet retrieval drops to 222 terabits. This last band alone holds the largest volume of cold data, underscoring a prime opportunity for transition to archival storage classes like S3 Glacier or S3 Glacier Deep Archive. This duration-based analysis reveals a classic hot-to-cold data lifecycle, where data is accessed heavily in its early days and then gradually becomes dormant. With the majority of retrieval happening in the first 30 days and sharp drop-offs in access beyond that, a tiered storage strategy can drive major cost savings. By setting up automated lifecycle policies that transition objects to standard IA after 30 days and then to Glacier after 90 or 180 days, organizations can align storage costs with actual usage patterns. This approach not only helps reduce unnecessary expenses, but also ensures efficient long-term data retention. Amazon S3 Server Access Logs provide a powerful mechanism for tracking detailed access information at both the bucket and object level. Each request made to an S3 bucket, whether it's a read, write, delete, or list operation, is logged, giving administrators a comprehensive view into who accessed what, when, and from where. These logs are automatically delivered to a designated S3 bucket of your choice, where they can be stored, managed, and analyzed. Once the logs are available, they can be processed using services like Amazon Athena, Amazon OpenSearch, or CloudWatch logs, enabling deep and flexible analysis of access patterns, anomalies, or unexpected usage. From a security and compliance perspective, server access logs are invaluable. They support auditing for regulatory requirements, help verify that access policies are being followed, and allow organizations to investigate and respond to potential unauthorized access. Beyond security, these logs also offer insights that can lead to cost optimization. By understanding access frequencies and user behavior, organizations can make more informed decisions about applying S3 lifecycle policies or transitioning infrequently accessed data to lower-cost storage classes. To gain real-time visibility into Amazon S3 usage and access patterns, server access logs can be ingested into OpenSearch and visualized using a Kibana dashboard. The process begins by configuring S3 server access logging for the target bucket. Here, an administrator specifies a destination bucket where all access logs will be stored automatically. Once logging is enabled and logs begin to accumulate, the next step is to transform the log files into a format compatible with OpenSearch, most commonly JSON. This transformation is typically performed using AWS Glue, which can crawl the raw log files, extract the required fields, and output the structured data. Following the transformation, Logstash is used to ingest the JSON formatted logs into the OpenSearch cluster. With the logs now indexed, a quick test query helps confirm that the data is correctly parsed, searchable, and ready for analysis. The real power comes from the Kibana visualizations that can now be created from this data. You can build charts and graphs to monitor access trends, such as the number of requests over time, helping you identify peak usage periods. Top requester dashboards can highlight the most active IP addresses or IAM users interacting with the bucket, which is useful for detecting abuse or validating usage patterns. Error analysis visualizations provide a breakdown of access errors, such as 403, forbidden, or 404, not found responses, helping teams quickly spot permission misconfigurations or broken links. If IP addresses are included in the logs, a geolocation map can be created to visualize where access requests are originating from, offering another layer of insight for both performance monitoring and security audits. All of these visualizations are brought together in a centralized Kibana dashboard, giving teams an intuitive and real-time interface to monitor, analyze, and respond to activity within their S3 environment. Monitoring Amazon S3 with Amazon CloudWatch offers a powerful and proactive approach to understanding and managing your S3 usage in real time. CloudWatch delivers a wide array of detailed metrics that cover everything from storage consumption and API request activity to data transfer patterns, making it an essential tool for operational visibility and performance tuning. At the core, CloudWatch provides real-time monitoring of storage metrics, such as the total number of bytes stored, object counts, and bucket size. This helps teams stay on top of their usage and ensures they can forecast storage growth accurately. Equally important are the request metrics, which track the number of get, put, delete, and other S3 operations. These metrics help teams identify access patterns, monitor load distribution, and optimize the performance of their applications. CloudWatch goes beyond raw numbers by helping detect anomalies and security threats. For instance, a sudden spike in 403, access denied, or 404, not found, errors can be a strong indicator of permission misconfigurations or unauthorized access attempts. By setting up custom CloudWatch alarms, users can receive immediate alerts when thresholds are crossed, enabling them to react quickly to potential issues before they escalate. In addition to usage and security, CloudWatch tracks data transfer metrics, providing insight into the volume of data flowing in and out of S3. This is particularly useful for cost analysis and network performance optimization, especially in scenarios involving high-throughput data movement. For more advanced workflows, CloudWatch integrates seamlessly with other AWS services such as AWS Lambda, SNS, and EventBridge, allowing users to automate responses to specific events, like triggering remediation scripts when access errors spike. It also works hand in hand with AWS CloudTrail, enabling detailed tracking of S3 operations for compliance and auditability. It's also worth noting the two tiers of monitoring: basic metrics, which are updated daily and available at no extra cost, and detailed request metrics, which provide per request granularity and require CloudWatch advanced monitoring. Thank you for joining us in this video. If you haven't already, we'd love for you to subscribe to our channel to stay updated with our latest content. We look forward to sharing more insights with you in another video. Until then, keep exploring. And thank you for watching.